All right, so in this video, we're going to go over the 3 problem-solving examples that we did in class because the assignment that's going to follow this is going to be some applications. Some of the applications you're not going to need an example to figure out because maybe it uses skills that we've already used, but a couple of the applications you're definitely going to want an example of how to set it up, okay? So the first one, and this what you're looking at right here, is a PDF that I've attached to the absent work calendar. If you're able to print, that would be really helpful. You could print this off and then work through the problems with me. If you're not able to print, you could always just hit the pause key, write the problem down, and then we'll work through. So in this problem, Farmer Smith wants to enclose a rectangular region with an area of 31,000 square feet. All right, so area is equal to 31,008, right? Just kind of recording the important information as I go. The region borders a river where no fence is needed. So what is that going to look like? Well, the interesting thing about this problem is it doesn't really matter where you put the river. The river could border this side right here, okay? The river could also border this side right here. It doesn't really matter mathematically, just pick one side to be the river. And then what we're going to do is we're going to label the sides. So with this being a rectangle, these would be one side length and this would be a different side length. Okay? But it doesn't really matter, like I said, which one's X, which one's Y, and which one borders. Mathematically, it will all work out the same. And we know that she has 500 feet of fencing. So what are the dimensions of the enclosed region? We're going to basically find X and Y. So what we can do is we can start writing equations out of the information that was given to us. So the first equation is going to maybe be for the area. X times Y is 31,008. So we kind of have to think about this. Does having the border along the river, does that affect the area? And the answer is no. You can see right here that just because there's a river, the area is still the same. So X times Y equals 31,000. Well, the other thing that we have is we have the perimeter X plus Y plus X, and that will equal 500. So we would take 2 x's plus 1 y is equal to 500. So now what we've created is a system of equations. We needed 2 equations to solve this problem. The best method for this system is going to be to use substitution. So ideally, the easiest variable to solve for is going to be this y right here. So maybe we solve for y and we say y equals, and we subtract the 2x. All right, so if we know that y equals 500 minus 2x, we can substitute this into this y right here. So it's going to look like x, replace the y with 500 minus 2x equals 31,008. So we distribute, and what we see is we have now created a quadratic equation that we're going to solve. All right, so what I would work on before we solve is let's get this equation in standard form. I'm going to move the negative 2x squared. We've got plus 500x and then subtract 31,008 and get the equation set equal to 0. One more thing that I'm going to do before we solve this or think about how we want to solve it is I'm going to factor out a negative 2. In fact, I'm going to move my work up here so I have a little bit more room. So I do notice that all the terms are even, so I can divide out a 2. So it's going to be x squared, 500 divided by negative 2 is negative 250x, and 31,008 divided by negative 2 is going to make this plus 15,504. So by taking out the negative 2, and we can just divide both sides by negative 2, we basically are solving this related equation, which has the exact same answers, but the coefficients are smaller, which means it's a little bit easier to work with. This equation may or may not factor, and to tell you the truth, I'm not going to sit around and try to think of factors of 15,504. So I think the best method in this case would be to use the quadratic formula. We're going to take the opposite of b plus or minus the square root of b squared. Now we've talked about this a lot in class. I understand that it is a negative 250. But when you write down negative 250 squared in your calculator and you don't use a parenthesis, your calculator is going to miscalculate it. So I just always, for this b squared part, I just always write the positive b term because I know this is going to be a positive. Minus 4 times a times the c value. all divided by 2 times the a value. All right, so the biggest thing is I need to go into my calculator and I need to type in the part underneath the square root, which was what? 250 squared minus 4 times the a value times the c value. And that part under the radical is going to be 584. And I don't know if you realize this, but what I do notice is that 584 is in fact a perfect square. So let's write this out. 250 plus or minus 484 divided by 2, and we can simplify further and write the square root of 484 as plus or minus 22, all divided by 2, which means that the answers are going to be rational. So one of the solutions is 250 plus 22 divided by 2, and the other one is 250 minus 22 divided by 2. Well, the first thing that stands out to me is that we're going to get two positive solutions. So when I add 250 plus 22, and again, you got to make sure that you hit enter and then divide it by 2, I see that the first possible solution is 136x. Or I'm sorry, the first solution of x is 136. So one of the possibilities is that this could be 136. Well, when we take 250 minus 22 and divide by 2, I get another positive number, 144, which means it could also be 144. So what we find happening is we get two different possible answers. It could be 136 for the first dimension by, and we'll plug that back in. Well, I think the easiest place to plug it back into would be to plug it back into y equals 500 minus 2x. So if we go 500 minus 2 times 136, we see that the dimensions are 136 by 228. All right, we can put in some units. 136 feet by 228 feet. Well, the other possible dimension is going to be 144. So maybe this time we take 500 minus 2 times 144. And we get 212. So the other possible is 144 feet by 212 feet. So all different things can happen when it comes to solving these problems. It is possible to have a solution that there's only one answer. Maybe the other one would have been negative and it would have been extraneous. But sometimes what we see happens is there's two different possible dimensions, which is why you could have put the river on any side and you would have come up with these, okay? Because maybe if the river was over on this side, then it would change those dimensions. All right, so the second one that we're going to look at, and I probably should have said this earlier, but I do want you to keep in mind with this, that this video mainly is for how to set up the problems. And so at any point, if you feel like you understand this setup, please feel free to hit the pause key and work through and solve the equation independently, and then you can kind of fast forward and make sure you did it right. A 5 by 7 inch photograph is surrounded by a frame of uniform width. The area of the frame equals the area of the photograph. So first thing I'm going to do again is we need to start these by making a picture. I'm not going to just go and read this and know how to set up the equation. So this is the 5 by 7 frame, okay? And then we know that the picture is 5 by 7. So inside this frame, which is supposed to be the same distance all the way around, that this picture is a 5 by 7 picture. And what we also know, what we don't know is the width of the frame. So I'm just going to call this X, and it is the same distance all the way around. Okay, so anywhere you go around, it has a width of X. And we know that the area of the frame equals the area of the photograph. So what we basically need to do is we need to figure out what the dimensions are of the entire frame and the picture. So I need to write an expression that represents the entire outside dimensions. Well, I know that it's 5. I know that it's 5 from here to here. All right, I know it's 5 from here to here, but then we need to add x on this side and x on the other side, so the entire outside part is going to be 5 plus 2x, okay? And then similarly, if we know this is 7 and I add x here and x here, this entire part is going to be 7 plus 2x. Sorry about that. I don't know why it does this sometimes. Okay. All right, so this whole part is going to be 7 plus 2x. And if I take the length 5 plus 2x and times it by the width 7 plus 2x, it's going to equal the area. Now they said that the area of the frame equals the area of the photograph. So I know that the area of this photograph is going to be 5 times 7, which is 35. Well, the area of the frame is equal to that. And so I'm going to highlight this also in pink. And so both of these are going to be 35. And so this is going to be 35 plus 35. So we're going to basically set this equal to 70. All right, so what we need to do is we need to double distribute because we always got to work on getting our equation in standard form. Plus 14x, and there we go again. We end up having a quadratic equation to solve. So work on getting this in standard form, 4x squared plus 24x, and when I minus the 70 from both sides, our constant term is going to be minus 35. Question is, do I have a GCF? And this time, I do not. So again, I don't know if this equation is going to factor, so we're going to just go straight into the quadratic formula, and we're going to type in 24 squared minus 4 times the a term times the c term, which is negative 35, all over 2 times the a term. So let's go into the calculator and let's calculate that part under the radical. It's going to be 24 squared minus 4 times the a value 4 times negative 35. And the result is 1,136. Well, let's just test this out. Let's see if that is a perfect square, and this time it is not. Okay, so what I'm going to do is let's write this out as x equals negative 24 plus or minus the square root of 1,136 all divided by 8. Well, I believe the problem said rounded to the nearest thousandths. Well, the nice thing about rounding to the nearest thousandth is I don't need to simplify the radical. So let's type in our calculator, negative 24 plus 1,136 divided by 8. And then let's type in our calculator, negative 24 minus 1,136 divided by 8. So let's go type this in. Negative 24 plus the square root of 1,136, and then you need to hit enter. And we're going to divide by 8. Okay? And what we get is 1.213. So it is x equals 1.213. Now, we can go ahead and type this in, but you know what? Number sense tells me that if I'm going to take a negative 24 and I'm going to subtract it by the square root of 136, this is going to give me a negative. And in this situation, a negative isn't going to make sense for our width. So what we would say for our answer is the width of the frame is 1.213 inches all the way around. And that would be our solution. All right, so we got one more problem to go through that's going to help you with these applications. And the last problem that we're going to do is going to be about a rectangular shed that is 3 meters long, 2 meters wide, and 2 meters high. If each dimension is increased by the same amount, the volume is doubled. All right, so one more time, we're going to start with the picture. But the difference here is this is going to be a 3-dimensional picture because we're basically making a rectangular prism. All right, and what I'm given, and I'm going to kind of draw this. All right, so what I know is that the shed is 3 meters long, 2 meters wide, and 2 meters high. If each dimension is increased by the same amount, increased by means x. And I don't know how much I'm increasing it by, so that's what I'm going to call plus x. So if we add x to all of the dimensions, the volume is doubled. So what is the original volume when we take 3 times 2 times 2? So 3 times 4, the original volume is 12. So if the volume then what does it say, is doubled, the new volume is going to be 24. I'm sorry, it is 24, but it's going to be 12 times 2 because it's doubled, so the new volume is 24. So what we're going to do is we're going to set up a polynomial to get the new volume. This is going to be the length 3 times, oh, sorry about that. All right, give me a second to fix this. Okay, so what we got is we got our length 3 plus x. All right, 3 plus x. I'm so sorry about this. Um, I'm just going to erase it and do this again. This looks terrible. All right, 3 plus x times 2 plus x times the height 2 plus x, and that's going to equal 24. Okay, so what I'm going to do here is we are going to take a second to you know what? I'm actually going to, let me just go ahead and share with you kind of a shortcut about this is we're going to put this in our calculator, okay? Now what you need to understand is does the calculator necessarily care if the equation is in standard form? And the answer to that is no. The calculator doesn't really care. So rather than take the time to multiply this whole thing out, what I'm going to do is I'm going to see that in standard form, this is 3 plus x times 2 plus x times 2 plus x. I'm going to minus the 24 over, and I'm going to write this in standard form. So what we're going to do is we're going to go into the calculator, y equals, and I'm going to type in 3 plus x times 2 plus x times 2 plus x, and we're going to minus the 24, and then we're just going to kind of see what we have going on. So I have, let's see, it's going to be 3 plus x. So that's something that people always do in class is they take all their time to multiply it out and put it in standard form, only to find that the answer is a decimal that they're going to calculate anyway. So before we decide to multiply, let's just take a look at the graph and see what we have going on. And what I have here is this one root right here, which is going to be the solution to the problem. And we can actually calculate this in our calculator if we go into second trace and we go to 0. All right, I'm not sure if that root's rational or not, so the left bound again is going to be the left side of the root. So I can see right here that I'm in the negatives. There I am. Okay, so the left side is going to be down here. So I hit enter on the left side. The right side's going to be over here, so I hit enter, and then I take a guess right on the root. And what I get is 0.586, which is a good thing we went to the calculator because I was not going to be able to find that by hand anyway. And so when we solved for it, we get that x equals 0.587 meters, and that's what needs to be added to each side of the rectangular shed. All right, thank you. Sorry about that last example with it getting a little bit, the page kept moving on me. But that's how these problems are going to work. Hopefully this helps you complete the applications. Take a look at the absent work calendar, and I'll see you next time. Bye.